Hello, researchers. My name is Malcolm Shambana, and I'm here to take you once again in research methods. And today we are looking at data analysis, which is quantitative. And to be specific, we are moving away from our previous data analysis, which was descriptive statistics, to inferential statistics. If you haven't watched the video under descriptive statistics, I suggest you best go to my YouTube account, search for that video, so that you can easily connect as I'm taking through inferential statistics. Because these two items are related. It's a build up from the previous session. So sit back, relax. As usual, enjoy whatever you enjoy doing whilst watching this presentation. Thank you. So my name is Malcolm Shambana. You can catch me on +260 977 488 442. That's a Zambian number. You can text me or WhatsApp in case you have any query or any contribution or any other issue you need to raise. Any other concern, your concerns are welcome and corrections are welcome. You can also search for me on my YouTube channel if you want to see further videos, or as well as you need to subscribe for you to get notification for further videos, or you need to go to my channel to look for already recorded videos, and if you like them so that I'm also encouraged to produce more videos. So we are moving on to inferential statistics today, as I suggested earlier on. Thanks. So our learning objectives today, we need to understand what inferential statistics is. Also need to know the difference between descriptive and inferential statistics. That's why I insist that you revisit the previous video regarding the descriptive statistics so that you can easily catch up and relate. We also need to understand how and when to use the t-test. Though we might not go into details of computation of these items, we just need to understand when they are supposed to be used and what result is expected and what's the purpose of that test. The same goes for the analysis of variance, which is in short written as ANOVA. We need to understand when it's used and the result expected from that analysis. We also need to understand the chi-square test when it's used and the result expected. We also need to understand the correlation analysis. These are very they are not all of the tests which you need to know under inferential statistics, but these are common tests which may help you through your research studies, your thesis and dissertation. Thank you. So we move on to the details now. So what is inferential statistics? Usually students get a challenge when they hear anything to do with mathematical or statistical, anything to do with formulas, anything to do with computation. But today we are going to, as much as possible, to make it simple. Our aim today is to ensure that you understand the purpose of a particular test function. The purpose is the key so that it helps you know which tool to use when you are testing a particular uh, objective or aim or research question. So you would understand which tool to use, the appropriate tool to use. The importance is understanding and knowing how to interpret the results, what the results mean. So what is inferential statistics? Inferential statistics involves the use of various analytical tools to draw inference says about the population data from sample data. So the idea is you picking up a sample and drawing a conclusion from the sample about the entire population. For example, you pick 5 students from a class, you carry out a test, maybe a math test, and then you refer or maybe you imply that the score is most likely to be the score of the entire class. Then there you are inferring. That's what inferential statistics involves. A sample is randomly or unbiasedly picked from a population. It's supposed to be randomly and unbiasedly picked from from a population to measure the characteristics or parameter of that population. You pick a sample because it's not always that you are able to test the entire population, because most of the time the population may be huge and it may not be practical for you to perform that exercise. So it's an issue of picking a sample and then concluding from the sample about the entire population. When a sample is picked, its characteristics may represent that of a population or may not. There are times when a sample may truly reflect what's in the population or may be off, may not even be related to the population due to other extreme factors. So it's at this point you need to carry out some tests to ensure that that sample which has been picked represents the entire population. So to test if the sample represents the entire population, inferential statistics is used in any case. So inferential statistics is also used to predict future trends of a given population. You are trying to assess what's going to happen in future to that population. And in this case, we were supposed to look at regression analysis, but I've put it aside since it's something to do with prediction of the future population, and this is not a common exercise in academic research when it comes to inferential statistics. So we move on. The difference between descriptive statistics, which we discovered in the previous session, and inferential statistics, which we are discussing now, can be outlined in the. I'll show you a table, but in the meantime, what you need to understand is that descriptive statistics states the characteristics of a data set, be it a population or a sample. It's looking at how the data is being, what picture the data is presenting, what mean of the data, what curve of the data, what mode of the data, or the median. So it's more on a descriptive side, like the name suggests. But inferential statistics analyzes the sample of a population to make a prediction or a conclusion about a larger population. So there is a table here which shows some of the major differences between descriptive and inferential statistics. Definitely, we will look at the purpose. Descriptive statistics describes and summarizes data, whereas inferential statistics makes inferences and draws conclusion about a population based on a sample data. Data analysis under descriptive analyzes and interprets characteristics of a data set, whereas under inferential, Data analysis uses sample data to make generalized or prediction about a larger population. So here we also look at population versus sample. Under descriptive, definitely it focuses on the entire population or a data set. It can be also a sample under descriptive, just a data set or the entire population. And then under inferential, the focus is on a subset of the population, your sample. In order for you to draw conclusion, you need to come up with a sample, draw a sample from a particular population so that you come up with a conclusion or a prediction. Though today we are not dwelling on prediction, we are just dwelling on conclusions. Prediction has to do with linear or multiple regression. So when it comes to measurements, descriptive statistics provides measures of central tendency and dispersion. We had discussed this, so that's why I'm encouraging you to go to my previous video under the YouTube channel. Subscribe, you'll find it there. It provides measures of central tendency and dispersions, whereas inferential estimates parameters, tests hypotheses, and determines the level of confidence or significance in the results. These are the things we are going to be looking at. So examples of descriptive statistics are the mean, median, mode, standard deviation, range, frequency tables. This was discussed in the previous session. And today, though we are not going into details, we are going to look at, we are going to simply assess what tests are involved under inferential, which involves hypothesis testing. Regression analysis, we won't do that, but I've just given it as an example of an inferential statistics. ANOVA, we are going to discuss that. Chi-square test, t-test, we are going to discuss. There are several inferential statistics, but these are the ones we need to focus on at the moment. They are the common ones in your academic research, say your dissertation, your thesis, and so on, and other research methods you are trying to work on. And then the goals under descriptive is to summarize, organize, and present data, whereas under inferential is to generalize findings to a larger population. It just relates to even the word itself, inferential. You are inferring. So you generalize the findings of your sample to a larger population. You can also make predictions. You can test hypotheses. You can evaluate relationships and support your decision making, especially when you carry out regression analysis. Though I've restricted, like I've said. I picked this table from Simply Learning 2023 just to help understand the differences between your descriptive and the inferential statistics. So we come to our tests. These are tools or steps which you need to, there are several of them, which you need to take in order for you to come up with a conclusion about a population. So like I mentioned, there are several, and we have picked those which are academic, more and common academic tests which are used in your inferential statistics. So we start with the t-test. So the t-test is an inferential statistic used to determine if there is significant difference between the means of two groups and how they are related. So the key underlining word there is two groups. You are looking at two groups. And the means, the average, which we discussed in our descriptive statistics. One group has its own mean, the other one has also its own mean. Now you are trying to compare the differences in those means if they are significant. So, for example, it can be used to assess if there is a significant difference between the mean exam score of grade 9 pupils in Southern Province and Lusaka. So you compute the mean scores of total results, of course, for grade 9s in Southern Province, and also you compute the mean scores of total results for grade 9s in Lusaka Province. Then try to assess if there is a significance in differences of those means. There are two types of T tests, we must mention that. There is one, the independent T test, which uses two independent groups. Then there is also one paired t-test which uses same group but at different condition, maybe even at different times. So in our case, we have mentioned Lusaka, the exam, comparing the mean score of exams in Lusaka and Southern Province. Those are two separate groups. They're independent. Lusaka is independent from Southern Province. So once we are measuring those two different independent groups, then we are using the independent t-test. And then if we test maybe a classroom, a same class, maybe when maybe they are from doing exercise, how fast they can write maybe a particular test. Maybe they are from doing physical exercises, how fast their brains are running. So you are going to test when before they were doing before they did the physical exercise and after they did the physical exercise. You are looking at the same group but at different times and different conditions. Then there you're going to use a paired t-test. The formulas are slightly different, so though today we are not so much discussing formulas, that's why we'll keep that aside for the meantime. So we move to analysis of variance, ANOVA in short. This one tests if there is significant difference among means in more than two groups. Ignore the wording there. I think there's a repeat in the word among. So it's used to test if there is significance difference among means in more than two groups. Remember, in the previous t-test, we tested differences among means in two groups, which was Lusaka Province and Southern Province. We were looking at the test score of exams between those two provinces. But if there are more than two groups, you don't have to use t-test. You need to use ANOVA test. That's the one which is appropriate for testing means among groups more than two. So, for example, it can be used to assess if there is significant difference between the mean score of grade 9 pupils in Southern Province, Lusaka, Luapula, and Western Province. As you can see, the provinces are now four. So the applicable tool for testing the differences in the means among these groups is ANOVA. We move on to chi-square. The purpose of this test is to determine if there is a difference between observed data, expected data, if that difference is due to chance or if that difference is as a result of a relationship between variables. Of course, the variables you are studying. So the purpose is to determine if the difference between the observed data and the expected data is by chance or there is a relationship between the variables involved. There are two types of chi-square tests. So one is the test of independence. The other one is the goodness of fit test. So, the goodness of fit test under this chi-square is used to test whether the frequency distribution of a categorical variable is different from your expectation. So here we are looking at one variable, one categorical variable. What we mean by categorical variable is that it's not numeric. It's in word form. That variable is word form. It's not numeric. If that we are testing if that the frequency of its distribution is as we expect. Is it normal, or maybe it's something else? Is it exponential? Does it follow a binomial distribution? So we're trying to test that. And also there is chi-square test of independence. Here we are not looking at the frequency of distribution of one category, but we are trying to test the independence between two variables, if they are related or not related. For example, we talk of gender and the type of university program maybe students are enrolling in. So there, we are going to look at these categorical, we are going to break down the gender. We are going to look at female, male, and also look at university program in which they enroll in. Is it a social science or natural science? And here, most likely, the hypothesis will be that maybe male choose natural science as compared to female. So you're comparing those two categories. I'm not going to those details of computation. I'm just trying to give you an idea or maybe a definition of where and when you use such particular test. So in that case, we are just testing the categories among two variables, which is gender and and the university program. And that will also, from those gender, university, you can come up with a hypothesis to test. So don't worry about this definition until maybe we go into practical exercise. There is a summary which I'll give. Maybe it will still open up your mind. So we move on. So last but not the least, in today's maybe test, these inferential statistics test, we are looking at correlation. So correlation is a statistical measure that indicates the extent to which two or more variables fluctuate in relation to each other. This statistic measure is known as sample coefficient. So you are looking at a particular figure, a coefficient, on how two or more variables relate to each other. In such a case, you are looking at correlation. I'm not going to give computation or formulas like I've mentioned, but this is more like an introduction. So there are two types, actually there are four types of correlation which you would expect. There is positive linear correlation, there is negative linear correlation, there is non-linear correlation, there is also no correlation at all. So positive correlation, kindly note that the correlation does not explain causation. Let me give you an example. If you are comparing the weight and height, does not mean that when somebody maybe loses weight, may gain or lose height as well. But there is a correlation between weight and height. So causation, I think this is a topic for another day. we'll discuss under, I think, design methods, if I haven't mistaken. But let's focus today on these inferential tools, which you just need to know when to use them, as for now. So correlation, there is positive. Under positive correlation, you find that when one variable changes, also the other variable is changing or likely to change in the same direction. If it increases, the other variable also increases. If it reduces, the other variable also reduces. That's the case for positive correlation. And then there is also negative correlation where when one variable increases, the other variable reduces. So in this case, maybe if we increase the y variable, we expect the x variable to reduce. If we reduce the x variable, we expect the y variable to reduce. I can give an example, maybe if you increase the number, maybe the exercise time, maybe you are likely to lose weight. That's an example I can give on negative correlation. I can also give on positive correlation. I never gave an example. So on positive correlation, maybe I can say if you increase the study time, the scores will also increase. No, it's not. There are other factors involved. These are examples. That's why we mentioned that correlation does not represent causal relationship. Causal needs other factors to be considered. So there is also nonlinear correlation. There is a relationship, but it doesn't follow a straight line trend. That's a nonlinear correlation. There is also no correlation at all. There is no relationship between two variables. Maybe studying and maybe increase in height. There is no correlation. That's what we can discuss so far on these tools which you can use in your inferential statistics. These are actually wide topic. If we had to discuss each, it would take us maybe one session. Though I'll have time for that to discuss each in the recording. So please subscribe to the YouTube channel so that you can get a notification when I start discussing these in details. So I can summarize these tests under inferential statistics. So when you are using t-square, you are most likely using categories. You are using words under your independent variable. I'm here. We are under independent variables. What are your independent variables when you are using t-square? We are using categories. We are using provinces, which we looked at, Lusaka and southern provinces. That's under t-square. You are using categories. Your independent variables are numerical. You are looking at your exam scores. So if you have the independent variables which are in words, they are in categories, before you sort out, maybe you discuss the frequency. You need to know the type of tool or inference tool to use. So if you have two categories, and under independent variables, and maybe one dependent variable which is numerical, it's best to use t-square for your test. If you have more than two categories under your independent variables, in our case, and I'm here now, I'm looking at ANOVA. I've put three provinces. I've put Lusaka, Southern, and Luapula provinces, we have got three categories under independent variables. So the categories are more than two, so we need to use ANOVA. The dependent variable is numerical, so we need to use ANOVA since we have got more than two categories, which means they are not in numerical forms. There is Southern Wapura province under independent variable, and we have a numerical dependent variable. We use ANOVA. If we have categories as independent variables and categories as dependent variables, then we use chi-square. In this case, we had gender, which is male and female, as independent variables, and we had dependent variables on the courses they were choosing, which is social or natural sciences. So these are categorical, they are not numerical. So if you have such a scenario, you use chi-square. Please examine this table properly. And then when you have numerical independent variable and numerical dependent variable, you use correlation. In this case, we had the numerical dependent variable, which is time of study, and the numerical dependent variable, which is exam score. We used correlation. So examples in this case, please have a look at this table quite with so much interest. There are keywords there: categories, numeric, category, numeric, category, category, numeric, numeric. Those will guide you which test you need to use for your inference statistics. I hope that's clear. And then the examples below are of your hypothesis, of course, exam score is different between Lusaka and Southern Province. That's when you are using two categories which are being tested under T square. Then we have the other hypothesis under ANOVA. Exam score is different among Lusaka, Southern, and Wapura Province. There you have two categories, more than two independent categories. That's why you are using ANOVA. Then we have this example there. Also, the other hypothesis example is you have a category under independent, you have got categories under independent variables, also categories under dependent variable. So you use chi-square. And the example is of your hypothesis, females are likely to choose social science. Then you use chi-square. It can even be male are likely to choose, it depends on your interest of study. So you can use chi-square since you have categorical, categorical. Example under correlation, you have, is there a significant relation between time of study and exam score? So there you have got a numeric independent variable and a numeric dependent variable. So you use correlation. That's how you choose the categories of these tests. You use correlation. So the results most likely from this test is under t-square, you're going to have, there will be a formula, of course, it will give you a resulting probability, which you are going to test against your chosen level of significance. We won't go into details on that until we discuss these individually. It's the same case as ANOVA. The result of your test score is going to be a probability which you are going to compare with your chosen level of significance. Under chi-square, the result is a probability which you're going to compare against the your chosen level of significance, and under correlation, you're going to have the effect size, which is you're going to determine the effect of the relationship between your two variables, the independent and the independent variable. See if it's significant or insignificant. I think, let me not confuse things. I think we end here for today. You can subscribe to my YouTube channel, Malcolm Shambana, and then you'll be able to receive subsequent videos, of course, relating to these, to the detailed studies of these things we have just introduced. So thank you for today. Thank you for watching. I end here.